Today I am going to discuss determination of positions of elements in the periodic table. In this lesson, the points to be discussed are MPT and MMPT, periods and columns, rules with examples, positions of inert elements, position of lanthanoids, and lastly position of actinoids. So let's begin. The very first point is MPT and MMPT. MPT stands for modern periodic table and MMPT stands for most modern periodic table. What is the basic difference between these two terms? The basic difference is in MPT, that means in modern periodic table, almost all the columns are subdivided into A and B. But in MMPT, that means in most modern periodic table, all the 18 columns are from 1 to 18. No subdivision in most modern periodic table. Now let's see periods and columns in the modern and most modern periodic table. Periods and columns. In the modern periodic table and most modern periodic table, there are 7 periods. Those are first period to 7th period. And columns are in the modern periodic table 1A to 7A. Total 7 periods. 1B to 7B, another 7 periods. Then column 8 with 3 columns. Another column, that is 0, this is 1. Total 18 columns. 14, 17, 1. 18 columns. This is in the modern periodic table. There are 18 columns like this. That is, columns are subdivided into A and B. But in MMPT, most modern periodic table, the columns are 1 to 18 simply. This is periods and columns in MPT and in MMPT. Let's see the next point. Now the point is rules with examples. Here there are 2 points, that is outermost shell and outermost electronic configurations. These 2 points are very much important. That is, outermost shell determines period and outermost electronic configuration determines columns or groups. And now let's go to the detail. Rule number 1 for S block elements. S block elements, the elements in which last electron enters S orbital, and S electrons. S block elements always belong to A subgroup, not in B. And if it is S electrons 1, then the column will be 1A or 1 in the most modern periodic table, and in the modern periodic table it will be 1A. If it is S electron 2, then the element will be in column 2A or 2. Now let's see one example. Potassium 19, 1s2, 2s2, 2p6, 3s2, 3p6, 3d and 4s. Up to these 18 electrons are accommodated. One electron left that enters the s orbital instead of 3d. Now the question may arise that why last electron of potassium enters s orbital instead of 3d? Because the energy of 3d is 5 and 4s is 4. So 4s orbital is lower energy orbital than 3d. That is why, according to Aufbau principle, last electron enters 4s orbital instead of 3d. Now let's go to a point, that is last outermost shell determines period. Potassium period is outermost shell is 4th shell. So potassium belongs to 4th period. And what is its group? Outermost electron, only one electron. So its position will be 1a or simply 1. Now the position of potassium is, it is in the 4th period and in column 1a, or in the most modern periodic table it is 1. Let's see another example. Calcium 20, 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. The period of calcium is, last shell is 4th shell, outermost shell determines period. So it belongs to the 4th period. And what is its group or column? In the last shell, that means s electrons are 2. So it is in the 2a or 2 in the, this is 2a in the modern periodic table and 2 in the most modern periodic table. So calcium in the 4th period and in column 2. Now let's say what is rule number 2. Rule number 2 is for p block elements. P block elements are those elements in which last electron enters p orbital. And here s and p electrons are involved. If it is s and p electrons, if it is 3, then the period will be 3a, or in most modern periodic table 10 is added to this 3, that means 17, not 17, it will be 13. If it is 4 electrons, then 4a or 10 plus 4, 14. If it is 5 electrons, 5a or 10 plus 5, that means column number 15. If it is 6, then 6a or 10 plus 6, 16. If it is 7, then 7a or 10 plus 7, column number 17. Now let's see one example. Potassium, phosphorus 15, 1s2, 2s2, 2p6, 3s2, 3p, 3. Here 10, 12, 15. Now the period of phosphorus is last shell is the third shell. Outermost shell determines period. So it belongs to third period. Now let's see group in the modern periodic table and in the most modern periodic table. In the modern periodic table, the group is 5 electrons, so 5a. And in the most modern periodic table, its position will be 5 plus 10, that means 15. So phosphorus belongs to third period and its group is, in the modern periodic table, it is 5a, and in the most modern periodic table, it is 15. Let's see another example. Chlorine 17. 1s2, 2s2, 2p6, 3s2, 3p5. This is 17 electrons. Its period is, last shell is the third shell. So chlorine belongs to third period and its group is, in the modern periodic table, 5 electrons, so 5a. S and p block elements will be always in a subgroup, that is why 5a. And in the most modern periodic table, 10 is added to this 5. Here it will be 7 electrons, so 7a. This 7 is added here to 10, so it is 17. Now the position of chlorine is in the periodic table. It belongs to the third period and its group is, in the modern periodic table, this is 7a, and in the most modern periodic table, this is 17. Rule 3 is for D block elements. D block elements are those elements in which last electron enters d orbital. Here d and s electrons will determine the column of the d block elements. D block elements always belong to B subgroup. If d and s electrons, d orbital electrons, that is penultimate shell d electrons and outermost shell s electrons. If d plus s electrons is 3, then the column will be 3b or 3 in the most modern periodic table. If it is 4, then 4b or 4. If it is 5, then 5b or 5. If it is 6, then 6b or 6. If it is 7, then 7b or 7. If it is 8, 9 or 10, then it will be column 8. Because column 8 consists of 3 columns. If it is 11, then it will be 1b or 11. If it is 12, then 2b or 2. If it is 11, then deducting 10, the column in the modern periodic table is determined. If it is more than 10, then 10 is deducted to get column in the modern periodic table like this. Let's see one example. Scandium 21. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. This total 21 electrons. Its period is last electron enters fourth period, so it belongs to the fourth period. Last electron enters fourth shell, so it belongs to the fourth period, and its group will be D and S electrons 3, then 3b or 3, 3b or 3b in the modern periodic table and 3 in the most modern periodic table. Let's see another example. Now let's say manganese 25. Electronic configuration is 3d5, 4s2. Its period is fourth period because in manganese up to fourth shell electrons are accommodated and its group is 7 electrons, so it will be 7a or 7. Let's see another example. Now let's say iron 26. Electronic configuration is 3d6, 4s2. So its period is fourth period and group is 8 electrons, so it will be 8 or 8 in the most modern periodic table. And if it is D and S electrons 8, 9 or 10, then it will be column 8. So here 8 electrons, so it will be 8. So iron belongs to the fourth period and column 8. Let's see another example. Now let's say nickel 28. Nickel 28. Electronic configuration is 3d8, 4s2. Its period is fourth period and group is, if it is 8, 9 or 10 electrons, then it will be column 8 in the modern periodic table, and in the most modern periodic table it will be 8 or 9 or 10. Here 10 electrons, 8, 9 or 10, then it will be group 8, or for 10 electrons column 10 in the most modern periodic table. So nickel belongs to fourth period and in column 8 in the modern periodic table, and in the most modern periodic table it belongs to column 10. Let's see another example. Now let's say copper 29. Copper 29. 3d10, 4s1. Its period is fourth period and group is 11 electrons total. If it is 11 electrons, then 1b in the modern periodic table and in the most modern periodic table it will be 11. In the modern periodic table 10 is deducted from 11 electrons, then we get 1, this 1b. If we see zinc 30, 3d10, 4s2, its period is 4th period and group is 12 electrons, so it will be 2b deducting 10, and in the most modern periodic table its group will be 12. So copper in the 4th period and in 1b group or 11 group, and zinc in the 4th period and zinc's group is 2b or 12 in the most modern periodic table. Let's see the next point. Now the point is position of inert elements. These are the inert elements: helium, neon, argon, krypton, xenon, radon, oganesson. The name of this group is 0, or in the most modern periodic table this is 18. 0 in the modern periodic table and 18 is the most modern periodic table. Now let's see examples. Helium 2, 1s2. So its period is 1st period because its last shell is the 1st shell. Outermost shell determines period. Let's see another example, that is argon 18. Here it is 3s2, 3p6. So its period is 3rd period. Let's see another example, xenon. Xe xenon 54, 5s2, 5p6. Its period is 5th period. 1, 2, 3, 4, 5. 5th period. So this is about the positions of inert elements in the periodic table. Now the point is position of lanthanoids. There are 15 elements, lanthanum to lutetium. These 15 elements are called lanthanoids, and in the periodic table there is a specific place of lanthanoids, that is 57 to atomic number 71, and it is in the 6th period and group is 3b or 3. So all the 15 elements lanthanoids, there is a fixed group, that is 3b or 3, and these 15 elements belong to 6th period. Let's see the next point. Now position of actinoids. In the periodic table, actinum to lawrencium, these 15 elements are called actinoids, and all these 15 elements belong to a specific place in the periodic table, that means atomic number 89 to 103. All the 15 elements belong to just one place, and it is in the 7th period, and group is 3b or 3. 3b in the modern periodic table and 3 is in the most modern periodic table. Now today, thank you very much.